Okay, so what is suitable for my business? And I guess we sort of prompted to give you a few hints while I'm showing the previous slides. Go to the next slide. Okay. So in the food processing industry, I guess there's an important driver, which is normally you have high heating loads because of the thermal processes that are present in the food processing industry. So things like cooking and blanching and those sort of things will you have a high demand for steam or food water, and if we combine that with the recent changes we've seen in the energy market, particularly the increase in natural gas prices, then that's why we're seeing that a number of businesses are then starting to look at what alternatives do I have to deal with these increases in energy cost, and what are my options, and we started to look at alternative fuels and trying to have a better understanding of how to use these things, which is one of the key barriers, I guess. What we've seen so far is that there is a lack of understanding of around waste to energy, and not just in terms of the say the technological aspect, but also because of what's available, and can I actually use this material in my process. So I guess there's still a way to go in terms of education and just trying to increase the level of understanding around waste to energy. But I guess the other key barrier is that these sort of products are generally very high capital cost, and some businesses have been having limited access to capital. So it's about having access to funds, and also thinking that these are long-term projects. And we're talking about 15, 20 years in horizon. So we'll talk about a little about what can we do about this barrier, how to overcome it later on. But it's important that we'll think that it's not a quick retrofit. If you're thinking about implementing a full biomass heating system, for example, or anaerobic digestion. So we're talking about large expenditure, probably in the order of $1 million. However, there's a few examples that can be best suitable for smaller scale applications. So I thought I'd include this table here just to show what's happening when you start looking at different applications, different sizes, and not only in terms of the investment fund, which obviously increases it, but also what are the things that I need to consider in terms of the space that I have available to accommodate for storage and material handling equipment. So the advantage is that as soon as you start decreasing the size of your biomass system, then your logistics costs will also become much less simple. and not only in terms of storage, but also, the sort of carbon fusion idea of, in terms of transport, how much trucks, how I'm going to get access to these materials. Is it going to be delivered to site, and therefore what's the cost associated with transporting these materials if you're getting it from external sources. So I guess this is a good example of as soon as you start changing the scale of the operation, what's the implication then on all these other different aspects? All right, so let's review a few examples. I picked this one from the city of Mount Gambier in South Australia, where they installed a biomass boiler to heat up the public swimming pool. And originally they were using a gas boiler, and it was due for replacement. And they thought about the idea of putting a biomass boiler because they had access to a good source of dry wood chips in the nearby area. So they decided to go ahead with this, and they installed a 650 kilowatt biomass boiler that uses around between 5 and 10 cubic meters a day of dry wood chip, which is sourced from the local forestry industry. But it can also run on salt as a supply from a local mill. The salt is obviously has a high moisture content, and because of it's a much sort of fine fuel in terms of it has a smaller particle size. It creates more problem or reduces the efficiency of the process. It's much cheaper compared to using wood chips, but wood chips, because being a drier sort of waste, then ensures that the boiler is running more efficiently. I think I don't have the cost for implementing this project, but there's a case study available, and I mentioned that the payback was 4 years when comparing it to replacing with a gas boiler. It has been operational since 2013, so if you take into account that gas prices are not going up, it might be that if you think about implementing a project today or in a couple of years time, then you might not get a payback, but it's within 3 years or maybe lower, depending on the specifics of the project. Go to the next example. It's a biogas example from Barry Bay Hillary. This project was implemented a while ago in 1989, and it's using the slurries and manure generated from the piggery in a digester to generate around 1,700 cubic meters a day of biogas, which is then used in a cogeneration unit. So that's the Caterpillar biogas engine you see up here, to generate heat and power that used in the farm. So it's a good example of a medium size, and I spoke about early on the applicability of these technologies in farm scale applications, and I guess this is a good example of it in Australia. the power that's generated is consumed on site. 60% of that of what's generated is it's enough to power the feed mill in the farm, and the rest gets exported back to the grid. So when we'll talk about savings that you can generate from this sort of project, then it's not just the offset of natural gas or whatever the existing supply of energy is in your site. There's also other savings that you can create from this. So in this case, it's in the form of not only offsetting purchased electricity, but also being able to export electricity back to the grid and getting a revenue out of it. Capital cost, being a digestion process in a tank, it's more expensive obviously than a covered lagoon. This case was $2 million, but the savings were also significant, and my understanding is that they received some funding from the government to implement the project, and had a payback of 5 years. So I guess it's not too bad. So let's focus now on what are the key factors that need to be considered when developing